All right. Good evening. You're welcome to today's lecture. Today we'll take a look at chemistry. Chemistry. We are still discussing chemical bonding. In our last class, we we stopped somewhere in um, electronic or ionic bonding. We stopped at the properties of compounds formed from ionic bonding. I gave an assignment that yesterday. I told you to do something. So without wasting time, I would want to do it so we can move on. I talked about formation of magnesium oxide and magnesium chloride. Magnesium oxide and magnesium chloride. So okay. So let's go. Let's start with magnesium oxide. Magnesium oxide. So we look at the bond between magnesium and oxygen in magnesium oxide. You know the atomic number of magnesium is 12. Is 12. That of oxygen, that of oxygen is what? What is the atomic number of oxygen? That is 8. This marker is not writing well. Please hold on for me. Let me. Okay, let's continue. So you can see on the board, this one is configuration 282. This one is 6. 2 plus 6, 8. 2 plus 8, 10 plus 2, 12. So for magnesium at the outermost shell, we have 2 here. Oxygen is 6. So magnesium can easily lose 2 electrons to attain octet structure, octet configuration. Whereas oxygen can easily gain 2 electrons. If you add 2 here, it becomes 8 to attain what? Octet what? Configuration. As you can see, 2 of them. But here now, once magnesium loses electron, that means the number of proton is more than the number. Once magnesium loses electron, excuse me, let me show that this next piece of me. Okay. Once magnesium loses electron, it becomes magnesium ion, positively charged because number of protons is more than number of electrons. So here becomes what? Magnesium. This is magnesium ion. And once oxygen gains the two electrons to complete its octet structure, it becomes what? It has two. This one now, if you lose two electrons, the number of proton will be more than the number of electron by 2. That's why you have +2, showing 2 extra positively charged. Then if oxygen atom gains these 2 electrons, it becomes negative, it becomes 2 negatively charged extra, 2 electron more than the proton. So it becomes, that's why you have 2 negative charge here, 2 charges. So that's what happened. And this is how they will exist in the solution. They will exist like this in the solution as ions. This is how they will exist in this solution, whatever. This is how they will exist in the bond. Magnesium ion and what? Oxide ion. So that's why it's called magnesium oxide. No longer magnesium and oxygen. Magnesium oxide. So this is basically what happened in magnesium oxide. Okay, so now for this thing can also be represented as a Lewis structure. It can also be represented in Lewis what structure? Lewis structure. Where you have we have something like this. Where you have something like this. Magnesium. The atomos electron. 1, 2. Plus oxygen. The atomos electron. 1, 2, 3, 4, 5, 6. And when they combine, we have something like this. Magnesium ion, because it will lose 2 electrons. Magnesium ion. And this electron will come here and get attached. So we have something like this. Is that clear? Where you have 2 minus. So this is magnesium oxide. Magnesium oxide. So this is, I'm trying to represent it with what? Lewis structure. Now, let's look at magnesium chloride. Let's look at magnesium chloride. Where you have magnesium C12, and we have chlorine. You know that chlorine is diatomic. It's not monatomic. Chlorine as a gas is diatomic molecule. So we have 2 molecules of what? Chlorine. 2 atoms of chlorine, sorry. 2 atoms of what? Chlorine. Now, remember that atomic number of chlorine is what? 17. Structurally, this will look like. Remember, there's a bond already, there's an already existing bond in this diatomic molecule between 2 chlorine molecules. So we have this is how it will look like. Or but let me not confuse you with the molecules. Let me leave it like this because it's atom to atom. So let's see what will happen. We have here is what. See what will happen. We have 2 8 2 magnesium. Here we have Here we have 2, 8, 7 from chlorine atom. But magnesium can only, we lose 2 electrons. If magnesium loses 2 electrons, it will come here and get attached. Here, chlorine atom will accept it. But chlorine atom, for this to be octets, chlorine atom, an atom of chlorine can only accept 1 electron. Look at it. To make it, to complete this, make it an octet configuration. That means we need an extra chlorine atom to complete it. So we need another chlorine atom to complete it. So if 2 electrons move from here, 1 will come here, the second electron will come here. We now have something like this. 2, 8, 8. Here becomes what? 2, 8, 8. So it's now complete. It's now complete. So at the end, if this happens here, here becomes what? Remember here will become negative. Here is negative. So here becomes what? 2, 8. Here is 2 positive will be here. So bringing in the symbol of the atom, we have magnesium 2 plus. Here, chlorine, one of the chloride, one of, because here is now chloride, it's no longer chlorine now. One of the chloride, the second chloride. That's why we have something like this: 2 chloride ions. 2 chloride ions. So this is how it will exist in the bond: magnesium ion and 2 chloride ions. So this is what it is: 2 moles of chloride ions. Sorry. Please, if you have any question, feel free to ask. So this is what happens in magnesium chloride. And that's why if you want to do transfer of valency now, this might, you know that here is 1. 1 will come here. These 2 will come here. We now have magnesium chloride. That's why 2 is here. For that of magnesium oxide, we have Mg2 plus O from oxygen. Transfer of valency, we now have Mg2 O2. 2 cancel 2. That's why the formula of magnesium oxide is MgO. This one is another topic when we go to chemical formula, but it's better you understand where all this came from. So that's why magnesium chloride is like this, and magnesium oxide is like this. Okay. Okay, so now this can also be represented in Lewy what structure as magnesium dots. Then we have plus one of the chlorine atoms. 1, 1, 3, 4. Remember, we are taking the outermost electron. 5, 6, 7. Plus the second chlorine atom. 1, 2, 3, 4, 5, 6. 5, 6, sorry, 7. So if they combine now, this one now will now lose these 2 outermost electron and they will get attached. This one will get attached here. This one will get attached here. We now have, once this happens, this becomes ion. 2 electrons gone. So 2 plus extra 2 electrons will be on top. We have, so I mean, two proton extra will be there. So we have magnesium 2 plus. This one now that accept one electron, we have one electron surplus. That's why it's like this. This one we have one electron here surplus. That's why it's like this. When these two are combined to become 2 chloride ion, this is magnesium ion. So this is how it resists in water solution. All right, so the same thing goes for calcium, because magnesium and calcium the same in the same group with 2 elements. So the same thing. If you have magnesium here, the same thing. If you have calcium here, calcium here. If you have calcium here, the same thing with magnesium. But magnesium and calcium are in the same group. So calcium can be here. Calcium can be here. That's why the chemical formula of calcium chloride is CaCl2, just like magnesium, MgCl2. We did that of sodium chloride last week. Please watch the previous video on this the bonding we did last week. It's clear. So that's where we draw the curtain for ionic bond. So let's go over to the next. Unless you have a question to ask. If you have any question, please feel free to ask, okay? All right. So in the absence of any question, we will move over to the next type of chemical bond. Next type of bond. Covalent bond. Covalent bond. So let's look at covalent. Bond. We described this covalent bond yesterday. Covalent bond involves sharing of what? A pair of valence electron by 2 atoms. So this one is quite different from ionic bond, where we have transfer of what? Electrons. So the bonds we are talking about now, the shared bond now leads to what? Production of what? Stable molecules. Stable molecules. So of course, in sharing the valence electron, they also target what? Establishing what? Stable octet configuration or duplex configuration of nearest noble gas. Now, in the simplest covalent bond available is hydrogen bond. The bond in hydrogen gas. You know, hydrogen gas is diatomic. Hydrogen gas is what? Diatomic. That is the simplest covalent bond available. Then halogens also have such bond, because halogens, I think I've talked about it now. Halogen is like this. Halogen, like chlorine, is like this. Fluorine is like this. There are many of them. Halogens are like bromine, iodine. These are halogens. They also exist like this. Oxygen also exists in the atomic. I think I have mentioned the bond between these are what? Covalent bonds. Covalent what? Bonds. Now, let us look at a hydrogen, which I mentioned as the simplest. In hydrogen, we have something like this. You know, Lewis structure makes it simple, so I prefer using Lewis structure. This is what hydrogen atom has one electron. Another hydrogen atom, one electron. When they combine, you see this and this will come together. This will bring contribute, they will share. You have something like this. This means they are sharing the pair. And this is translated in that thing. Anytime you see something like this, it's talking about this thing in chemistry is equivalent to is a bond. But a bond is made up of two single bond is made up of what? Two electrons. A pair of what? Electron. So this also can be represented as this. Now let's look at for chlorine. You see something like this. Chlorine atom. You have, you know, we have 7 in that outermost shell. 1, 2, 3, 4, 5, 6, 7. Then another chlorine atom. So this one should be here because this is where the bonding will take place. Another chlorine atom, we have 1, 2, 3, 4, 5, 6, 7. See what will happen. This and this will come together. We have something like this. Chlorine. Then we have these two, we align like this. We have something like this. Not chlorine. So we now put the other ones. We have this, and this. Here we have this, and this. Now, if you check each of the chlorine atom now, each of them. If you check each of the chlorine atom, each of them has each of the chlorine atom now has complete octet configuration in the outermost shell. This dot and this dot is the electron in the outermost shell, not all the entire. In Lewis structure, you just bring out the electron in the outermost shell only. We are not going deep into the full electronic configuration of chlorine. So if you want to go into full, we have something like this: 2, 8, 2, 8, 7. This would have been had it been is in a equivalent bond where chlorine will accept electron without bringing an electron to share. This would have become chloride once it's completed. But because it gets completed and exists as a molecule, they are bonded like this as a molecule. In the ionic bond, you have energy like this. They are not bonded together like that. They are ions, but this one is not ion. This one is a molecule. A molecule of chlorine is made up of what? 2 atoms of what? Chlorine coming together to share electron. So here is 1, 2, 3, 4, 5, 6, 7, 8 completes.